Hello everyone, today we will be talking about U-substitution with logarithms and exponents.
The formal definition of the substitution rule is, for indefinite integrals, if u equals g of x is a differentiable function whose range is an interval I and f is continuous on I, then the integral of f of g of x times g prime of x dx equals the integral of f of u du. For definite integrals, if g prime is continuous on the closed interval from a to b, and f is continuous on the range u equals g of x, then the definite integral from a to b of f of g of x times g prime of x dx equals the definite integral from g of a to g of b of f of u du.
So, what is U-subbing logs and exponents? U-substitution with logarithms and exponents is just what it sounds like, substituting in a variable u for logs and exponents. It's also a technique used for integrating or solving integrals. So, the method of approach. Essentially, substituting an expression that complicates the integral into a single variable, usually u, which you will be using to manipulate the integral for it to be easier to solve. For definite integrals, remember to plug in the closed interval a to b into the u-sub to get the new bounds for the integrand in terms of u.
Here are the general steps to solve an integral with U-substitution. 1. Let u be a function.
2. Determine dx.
3. Substitute dx with du.
4. Integrate the integral with u.
5. Change the bounds of the integral.
6. Solve the integral with new bounds. Let's do some sample problems. Alright, so our first sample problem here is the definite integral from 2 to 4 of e to the 1 over x squared dx. Alright, so this problem, we first need to find something to substitute into u. That's why this is called a U-substitution. And this 1 over x right here looks particularly nasty to deal with. So let's substitute that into u. U is equal to 1 over x. And now, by taking the derivative of both sides, we get du is equal to negative 1 over x squared dx. Now this dx came from, normally Leibniz notation is written like this. So then we can multiply both sides to get this dx over here. So now we got what we need to substitute into the integral. So now we can substitute this u into the integral. So we get the definite integral from 2 to 4 of e to the u. And now in order to put du into this integral, we need to replace dx along with this. And conveniently, we have a 1 over x squared, but we're missing that negative. So we can tag it outside, because negative times negative is positive. And now we got rid of this. So we get negative definite integral from 2 to 4 of e to the u, du this time, since dx got replaced. And now it's easy to solve this. Now, really quick before we solve this, we notice that these two bounds, 2 and 4, were for x. So we need to change them. So we can put the bounds into this equation over here to get the new bounds. So with the new bounds, we get negative definite integral of 1/2 to 1/4 of e to the u du. Now, with this, we can just solve the integral as we would always do. So this equals to negative e to the upper bound, 1 over 4, minus negative e to the 1/2, because 1/2 is a. And I forgot to mention, the antiderivative of e to the u is e to the u. So now we have this by the fundamental theorem of calculus, and we can solve, which equals to negative e to the 1/4 plus e to the 1/2, which is something around 0.365.
It looks like we have another nasty problem over here, and we can utilize U-subs with logs this time. So let U equal ln the natural log of 3x squared. 3. We're going to take the derivative of this. So du equals 1 over 3x squared. And be sure to use the chain rule, so times 6x. We get that du equals 6x over 3x squared dx. Okay, we're going to move 6x over 3x squared to du side, so 3x squared over 6x du equals dx. Now we're going to plug dx back into the original equation, with the integral. So we would do the integral, the indefinite integral of 6x over 3x squared times 3x squared over 6x times 2 to the u du. These terms cancel out, so we're left with the indefinite integral of 2 to the u du. So the antiderivative of 2 to the u is 2 to the u over L and 2. Now we have to plug u here back into this antiderivative. So it would be 2 to the L n of 3x squared over L n 2. And don't forget the plus c. Now to common errors. Remember to change the bounds after the U-substitution in a definite integral. Remember to add c when solving indefinite integrals. Remember that you are taking the derivative of the u-sub. U equals g of x.
Remember that the derivative of ln of x is equal to 1 over x, and the derivative of log base a of x is 1 over x ln a. Also known that the derivative of a to the x is equal to a to the x times ln of a, and the antiderivative of a to the x is a to the x over ln of a. Thanks for watching.